Hi, my name is Wes. My amateur radio call sign is W3KW. On the bench today is what I think is pretty interesting demonstration here. These two capacitors are part of the power supply filtering network for a Sentinel ME26DU vacuum tube voltmeter. It's a militarized version of the HP410B and was used by most of the military services, and they were maintained in Tobyhanna, Pennsylvania at the Tobyhanna Army Depot. And you would send it there for restoration or repairs and calibration, etc. Well, that hasn't been done in over 40 years, so when you find one, they're going to have these crusty old capacitors in them. And I removed them and replaced them with new canned capacitors. You can see these are in pretty rough shape. It's 12 microfarad, and it's at, this one's the only one you can read here, 450 volts DC. So let's take a look at these things and see if they're healthy. A lot of people don't change capacitors if they look good. Of course, this is not looking good. Okay, I would never leave that in a piece of equipment I was restoring. But let's take a look. This is an Atlas ESR 70 Gold, and it's a not too expensive tester for capacitors. And all you have to do is hook it up here and turn it on. Oops. It's very quick. Polarization doesn't matter. It figures it out for you. So about 14 microfarad. And the ESR, which is what we're interested in, is only 0.28 ohms. Okay, so that's pretty low. Okay, is that a good capacitor? Well, we don't know yet. So let's take a look at the other one here. And again, polarization doesn't matter, even though these are electrolytic on this device, which kind of makes it handy. So that's even lower ESR, equivalent series resistance, and around 14 microfarads. Now, the problem is you don't know what frequency this is testing the capacitor at. And that can make a difference in the total value that you get. Now, all these multimeters and devices, LCRs you see behind me, test capacitors at different frequencies. Everyone has a multimeter for the bench, and they almost always have a capacitor setting, and you can check capacitors with that. This is an LCR meter by BK Precision. I think it's a really terrific and dependable unit. It's pretty accurate, and the beauty of it is you can change the frequency that you're measuring, which will change the value of the capacitor. And 120 hertz is what you might see in a typical power supply that these filters, or that these capacitors are filters in. So you can see it's also reading 14 microfarad, and this is at 120 hertz. Now, you can't do 60 hertz, which is surprising, but if you go through the frequencies here, and I can turn on the backlighting for you too. If you go through the frequencies, you see it'll change the rating that it is reading, or the result that it's reading. That's 1 kilohertz, 10 kilohertz, 100 kilohertz, all the way down into the nanofarad range. So you can see the frequency that you measure at, or that you use this device in your project, or where it's installed in the project matters. So 100 kilohertz is kind of a good compromise number between 60 hertz, which is line voltage, and 120 hertz, which you might get after your power supply rectifier. All right, so each of these devices here is going to have a means to do that, and they all turn out to be a pretty similar number. And by all results on each of these, it looks like a good capacitor, okay? But is it, okay? So what happens is DC should be blocked in a capacitor, and only AC should pass, right? Well, let's find out if that works on this capacitor by using the Heathkit IT28 And if you look at the window here, as I'm in leakage, and as I add voltage to the capacitor, the window will start closing at some point in the voltage range. And if it opens, it means the capacitor is good. If it stays closed, it means DC current is passing through the capacitor. So I'll start bringing this up. You can see it kind of flash. There's 100 volts, 150. Remember, this is 450 working volts. 200, 250, 300. You see it struggle just a little bit. 350, struggled a little bit. 400 volts. Okay, it eventually makes it. 450 volts. It makes it, but barely. But technically, I would consider that a good capacitor. The ESR is still pretty low. It measures in the capacitance range that we want, and the leakage is acceptable. So technically, this is a good capacitor. We'll go to discharge there, turn the voltage all the way down, and then disconnect. Okay, so even though this tests good, I wouldn't leave it in a device because it's leaking, or at least having a chemical reaction here under this. There's a laminate cover here. All right, let's try the other crusty one here. And remember, this is polarization matters on these. All right, so we'll go to leakage. This is all the way down. We'll go to leakage and start bringing up the voltage. There's 100, 200, 250, 300, 350, 400. This is 450. I would say this capacitor is at the end of its useful life. That there's definitely leakage at 450. Now, the working voltage of the device this is in is lower than that, but obviously this one is starting to go, and with the chemical reaction or crusty deposits coming out of this thing there, I would definitely pull it from whatever device it was in. All right, so we'll go to discharge, turn the voltage all the way down, and that part of the test is done. Okay, so here's an experiment I have set up so we can compare this old capacitor, which does test low in ESR and pretty close to its rated capacitance, versus a brand new capacitor. This is basically the equivalent replacement, except this one 450 volts, this one 500 volts, albeit at 10 microfarad. This one's at 12 microfarad. So again, let's test the ESR and the the rating of the old capacitor here, so we can kind of see our starting point with the two capacitors. So this shows 13.9 microfarad at 0.85 ohms of ESR, which is actually quite low. So you might think that capacitor is fine. Let's compare it to the new version. This indicates 11 microfarad at 1.69 ohms of ESR. The ESR, equivalent series resistance, is actually higher, almost twice as high in the new capacitor. And you might think, oh, well, let's put the old capacitor in. Well, not so fast. Let me show you what's going on here. I've got this test set up here. This is reading voltage. This is reading amperage. So let's go to leakage and bring the voltage up to 450. Now I'm only showing you that we have about 450 volts, and I can adjust it using a variac here for the input voltage, which in this unit is just below line voltage. There's 450 volts, no load. We're just coming out of the IT28 and going right into the voltmeter. So there's our unloaded 450 volts. Okay. Now let's put this old crusty capacitor in the circuit. So negative to negative. Remember, these are polarized. So then the positive comes out, goes through the ammeter, and so this is essentially positive. I'll put that on the positive side of the capacitor, and let's check it again. Remember, when the window closes, it's presenting DC leakage, and as the capacitor loads up, the window will open, indicating that it's okay. So there's 300 volts. It's struggling to hold 300 volts. You can see we're already at 1.3 milliamps of current, and though the meter's set to 300 volts, that is already a 50 volt load on this circuit. Let's go all the way to 450. Look at that. This capacitor that's rated at 450 ohms cannot even hold. It's allowing DC to pass to the tune of 2.75 milliamps, which is taking our 450 volt supply and bringing it all the way down to 347 volts. So that DC is going somewhere. And where it's going is right into your power transformer of your guitar amplifier or other device or instrument. So let's compare the new capacitor, which actually, if you recall, had a higher ESR, equivalent series resistance. Okay, so there it is in circuit. We'll go to leakage at 100 volts, 98.3 or 0.5 volts, very low current draw. 250 volts, still a very low current draw, 0.12 milliamps. 250 volt supply showing 245 volts. Let's go all the way to 450. The capacitor is, just charging up that last bit there, but only 0.12 milliamps load, and we're climbing well over 441 volts now. So this capacitor, if it were in your filtering network of your power supply, would be leaking very little DC current, which then ends up going through the secondary of your transformer. So if your transformer is hot, this could be the culprit right here, because that DC current is now flowing through your the secondary of your transformer. Anyway, so I hope that was a good demonstration of why it's important to test these for ESR, equivalent series resistance, and of course its rated capacitance, but then to also check for DC leakage, which can wreak havoc on circuits both in the power supply and beyond. I hope you enjoyed this video. If you'd like to learn more about ham radio, go to qrz.com or go to arrl.org. Give me a thumbs up, join the channel, comment if you want to see more. If I made any mistakes in here, definitely put that in there. I'm not an electrical engineer. I'm just a ham radio guy just like you. Anyway, happy hamming in 73.